Yo, what's up, everybody? Welcome back. Today, we are working on tokenizing text for a language model. The context here is that I sometimes want to watch movies, right? I will see an ad for Meg 2 The Trench, the world's best movie. I will click, I want to watch that at some point. And then later, when I'm in the mood to watch a movie, I go down to this list and I say, what can I watch, right? And the original design of this application was that there would be breakdown of things that are in theaters, released on DVD, and things that I've already watched, right? So that I could kind of filter for, I see ads for things when they're in the theaters. I don't like going to the theaters, right? The API that I was using kind of stopped having good home release dates, and it turns out that actually every single API that has home release dates is overly restrictive. I either have to pay them a fuck ton of money, or I'm not allowed to write down the dates that they give me, or else I am breaking their license agreement. And we could just break the license agreement, right? But this is kind of like a fuck you, right? And I kind of want a better solution. So we recently rewrote everything to get all of the movies information from Wikipedia. Right, so if I look up, I don't know, Spider-Man, right? Give him a sec, he's thinking, right? All of these posters and titles and stuff, these are coming from Wikipedia, right? So if I go to, Spider-Man 2, all of the, information about this movie is in this box in, a nice formatted way, right? It's got, key value store for this box, which is great, except that this box does not tell me when the movie was released on DVD, which is an important piece of information because that's when I can watch it at home, right? And, for lots of movies, you just assume, but a lot of movies, I hear about them as they come out. But this is, somewhat solvable, right? In here, there is a section where they talk about release, and usually they talk about, does Spider-Man 2 not have VHS release date or DVD? That's kind of funny. Oh, here we go. Post-release home media, right? So in here, they say that it was released on November 30th, 2004. But this is just text on a page. And so if I want to put this in my database and compare the date with that thing, I either have to I have to find some way to do that, right? So what we did yesterday or the day before was we trained a language model, a BERT named entity what does it stand for? Named entity extraction. What is NER? Recognition model? To try to pull out release dates, but not just any date, specifically dates related to media releases, right? So we should be able to give this page to our model, and it should be able to tell us these pieces of information, right? So I think if I run download page, hold on. I didn't download Spider-Man 2. I downloaded Spider-Man 1 earlier, but since I used Spider-Man 2 as my example, we have to use Spider-Man 2 as the example here as well. You know what I mean? Otherwise, it's not authentic. So what is this Spider-Man 2 movie? I need the title. I need the title. Here. Download this shit. Hold. This gives us something that looks like this, right? We do some pre-processing to this thing, right? I think that is under pre-process. This guy. Boom. Pre-process Spider-Man 2. So now we have Spider-Man 2 in here. And these are lists of paragraphs that we could feed to the model, right? But the one that we care about is probably one that says home media release or something in here. Skimming, post-release equals, wait, where the fuck was it? Where the fuck was it not? Oh, here we go. Post-release home media. So we're looking at Spider-Man 2 94. Spider-Man 2 94. So if I go in here and I say Spider-Man 2 94, give him this paragraph, run the model that we trained yesterday. This is running on CPU, and he extracts these chunks of text tagged with what type of release he thinks it is, and it took me around 34 milliseconds on CPU, right? Which isn't bad, right? And just to prove that it's not always gonna say this, if we give him the first paragraph, does he say anything? He says no date spans found, which makes sense because he only looks for theatrical or non-theatrical release dates. Do they have in here the release date in here? No, he doesn't. So anyways, the point is this model should, if it was working correctly, be able to extract dates of DVD releases. Perfect. The question is now, how the heck do we run this thing, right? We've run PyTorch to like make some model. There is like some chunk of PyTorch weights sitting in our Python program. And when I run this thing, like I am typing, hold here. I am typing tokenizer equals auto tokenizer from pre-trained. And then I'm like saying, run the tokenizer on some text. So I get like, take the chunk of, the paragraph, and I run it through whatever this function does, and then I feed that to the model, right? And the reason this is important is because the model itself is just kind of like a computation graph, right? It's just like a list of instructions to say, take this, whatever input you have, and feed it into this matrix, and then feed it into that matrix, then feed it into that matrix. He's got like a bunch of like operations that he can do, right? And you can like export that computation graph for consumption in other programs, right? So like there's this like thing called Onyx, which is like a way to represent this computation graph, and then they have like a runtime that you can use in other applications. Easy peasy, right? But like the thing is that this is only the computation graph part, but there's like a bunch of work that's being done here before the computation graph. It's like the part that you take the tokens, you take the text, and you turn it into whatever the frick the computation graph wants, right? And so the question is what is this doing? And like we should probably we're gonna write our own. We're gonna write our own probably, or at least we're gonna try to. Maybe we'll find out that it's not worth it. But that's kind of the plan. Is to like kind of figure out like what the hell does this thing do, and if we can write our own, do that. And that's the plan. That is the plan. So the training framework I'm using comes kind of from this like Hugging Face Transformers library in Python, right? And this is kind of like when you like Google, like, I want to download language model. This is like the place everyone posts their shit, right? So they're kind of like, they're trying to make our lives easy. And we're like, no, thank you. But I think that they have some library in here where you can like, I think it's just like a Rust library. Yeah, this guy. Right, so they have a thing, but I don't really want to like yoink in some sort of like pre-written Rust library, right? Like I'm willing to take like the computation graph execution engine because I think that that's like one going to be low dependency. Like if when you look at like what that thing depends on, it's like basically nothing. And then also like there's like actually interesting work to be done in there. Where like the tokenizer is like, I don't really want to pull in some like fucking random Rust library and then have to depend on that. Like we just rewrote our fucking TV tracker to get away from Rust to rewrite it in Zig. Why are we pulling a Rust dependency now? Unbelievable. Nuh-uh. So, yeah, let's kind of see, I guess, maybe we look at like in Python land, what are we doing right now? You know what I mean? What the heck is happening? And I think that there's some sort of like JSON schema for like what the inputs of this thing expect. I don't really know where that would live, but that's kind of like what I remember seeing. Maybe it's like downloaded as part of when I say, hey, auto tokenizer, you know about some pre-trained model, right? Like maybe he's downloading that something somewhere. You know what I mean? I think we saw when we ran the first time that he did try to like download some stuff. Where did he try to put it? I think he tried to like put it in here, this stuff, right? So somewhere there's like a tokenizer config and vocab. So where's he placing that? Are those like in here, or are those in like my maybe cache? Maybe they put it in cache, and we would look for Hugging Face. This is promising, right? So we are doing something that's like based on this guy, and this seems like the stuff that we are looking for. Oh, perfect. So this is what? This is like a list of numbers, maybe, that map to what chunk of text it represents, right? That'd be my guess. So probably like somehow this JSON file describes like the back and forth. So each chunk of a word maybe turns into a number, and this is the mapping of numbers to chunks of words probably, as well as like it looks like they have a bunch of like config options in here, right? That's just kind of what it looks like. What else is in here? vocab.txt. This looks like maybe another representation of the same thing, right? Like each line here could maybe be an index into what each token represents, right? Right. So like you see the number 2461 and maybe you see the word short come out of that thing, right? Maybe. And we could prove this pretty easily by walking the encoded text, loading this vocab, and just seeing if we spit out the encoded thing, if it looks like the thing we gave it. You know what I mean? You know what I mean? So maybe that's where we start. There's also tokenizer config, which is different than tokenizer. Interesting. What is tokenizer config? This says, hey, I want to lowercase my shit, I guess. This says I have an uncle token, sep token, pad token, CLS token. So these are probably like special characters for the model. I think that like maybe I've seen like the idea that you're like that the model knows that there's like a special character that you put at the beginning of input just to like flag to it that this is the beginning of input, right? Sep probably is like there's some sort of like separation between maybe like different chunks of queries and stuff. So this makes some form of sense. However, I don't really know why that's different than this. Okay. Other things to think about, what does this like truncation flag mean? Truncation, padding, added tokens. What else is in here? You know what I mean? Like this normalizer. Oh, interesting. So they have like some sort of token normalization going on. Pre-tokenizer. Okay. Interesting. Interesting. So what can we do here to like start trying to understand what is happening? I guess we would want to look at the tokenizer source code, right? Pass it to JQ. We have JSON parsers in our head. Okay, well, yeah, we can go back and look at the tokenizer Hugging Face repo. Oh, are we in it right now? I think we are. Is there an implementation in here? It is. Perfect. Okay, so this is like relevant information. We could use this as like a reference to some extent. I guess work. And then let's see if we can if our guess as to what that vocab is correct. I think that's let's start there. Vocab text. Right, so that should be as simple as let's say tokenizer test, maybe. So this guy, he is instantiating this like tokenizer through this thing. Boom. He needs to get that from this thing. Boom. And then one of his outputs, so he runs it like this. Boom. So let's run it on, hello, my name is Mick. Input, text. Let's do that. Let's do that. And then, what do we look at when we come out of these things? We have offsets, input IDs, and attention mask. So my guess here would be that offsets would be the, where in the original text this token came from. That would be my guess. Input IDs would be, I would assume that this is like the actual tokenized text. And then attention mask, maybe there's like certain elements in the text that we know that the model shouldn't look at. And maybe that's what this is for. Is that thing just makes it all the way down to the model, I think, right? Model, attention mask. Yeah, he just feeds this into Bert. So I don't know what the hell is going on down there, but Bert wants it. So maybe we give it to him, right? Okay. Cool. Maybe that's just for training, right? It might just be for training. It could be that your actual input is just this. Okay. So let's look at our input IDs. Where did they come from? Enc input IDs. Enc input IDs, right? And I assume that this thing will kind of scale. with the, oh, I guess we need to define what model we were pulling from, which was this guy. This was our base model. Model name. Just letting him do the lookup himself, you know? Okay, repo ID must use alphanumeric characters. Am I crazy? Oh, comma. Dude, I hate how in this language, if you put a trailing comma on stuff, it just, how do I say this? It turns it into a tuple, which is so annoying. Okay, so we are expecting something that is probably along the lines of like 1, 2, 3, 4, 5 tokens plus maybe a beginning and end, right? That would be my guess. 1, 2, 3, 4, 5 beginning end, right? That seems right? Like these are all like big numbers, and then these are like kind of numbers near 100, which are maybe like special character numbers, would be my guess. So I would hope that if we go to like that vocab.txt we were looking at, we look at line 7592, we should see hello. If we were, you know, maybe. So where the fuck was that vocab, by the way? It was here. I maybe copy this. Can we just copy the whole directory, maybe? Mini LM, like cache, we'll just say, because I don't know what this thing is yet. And can we open vocab? Oh fuck, they were soft links. ls-l, where do they go? Where the fuck do they go? Okay, fine. Dude, how can I copy with resolve symlinks? Dereference. Always follow symbolic links. Can I do that? If I do cp-rl? That seems correct. Oh, I see. We copied it into the directory because if the directory exists, it goes inside. Right. Okay, that's better. Okay, so I need to look at. We need to reference those numbers again. And then can we look at? So 7592. Okay, 7592. Good, we're off by 1 because the Vim line numbers are off by 1, but that does say hello. And then we can assume 2026 is my, right here. Perfect. Okay, so that means that we've already confirmed. We guessed this thing correctly. I'd be interested to see, by the way, what is at 100. Aha! Right, so off by 1, which way are we off by 1 again? It's hello, my is 2026 here, it's 27 here. So we need to add 1 to the number to find what it means in here. Okay, so if we see 101 at the beginning of the text, that's CLS, which I think is the correct end of or start of text thing. And then we see 102 plus 1 to 103, separator for end of text. That makes sense. This is crazy. How can they list all possible words? I think they list all possible subsets of words. And then I don't really know what they do in terms of how do I say this? I don't know if they what they do if they see stuff that isn't in an input dataset. I wonder if they have ways of constructing in sign language, if you don't have a sign for something, you spell it, right? I wonder if they have some way to do that. That wouldn't surprise me. That would not surprise me. Okay, cool. So that makes sense. But I would imagine that the tokenization process is not just going from just looking in that vocab.txt and mapping to words, right? There was more stuff in there. So I think that we want to look at maybe the tokenizer JSON. Fine, we'll fucking look at it. We'll fucking run it through JQ. And so what does he have? So he's got the vocab defined in here as well. He's got some things that say, hey, this is word continuation, so probably that makes sense. I don't know what unc means yet. But all of this stuff above seems like metadata, right? Well, some of it. I think that what it looks like is happening here is there was this thing called word piece who maybe existed before, and then they are attaching extra data to the existing word piece guy, right? Like here they have this added tokens thing, right? So there's this word piece database that existed, but then they're throwing some extra shit on top. Maybe, who knows, right? Padding, strategy fixed, direction right, pad multiple of null. Who knows? Who knows? Yeah, it seems like probably we just have to look at the tokenizer source code, right? I guess. Well, the other thing here that's confusing is the guys who trained BERT surely knew how their tokens worked, right? So maybe let's look there as well. Right? How did they do tokenization? Maybe this is a more interesting piece. I know this isn't the exact model we're using right now, but maybe this is useful information. Convert by vocab. So he literally 4 item in items output. Oh, this is what we just did, right? This is from, they have a list of tokens and they're trying to get words. But how do they go the other way? Full tokenizer, basic tokenizer. So this guy says he looks at the basic tokenizer and then the word piece tokenizer. Word piece tokenizer, is that a thing that they define here? It is. Perfect. They kind of have everything. Oh, word piece tokenizer is just splitting by subwords. Okay, convert to Unicode, makes sense. White space tokenize. So this is probably you're splitting text by spaces, right? Because spaces are not interesting text to the model, I guess, probably. Maybe paragraphs are, but you know what I mean? They're probably omitting double spaces and stuff like that, probably. And what are they doing here? They're literally just, ooh, okay, Unc token? Unc token is unknown. Unknown. So if they find a thing and they don't know how to use it, they just say Unc. Unc doesn't get it. Okay, that makes sense. And it looks like they probably just have vocab as a hash map here or something, right? That goes, if substr is in self vocab. Oh no, they're literally, yeah. So maybe self vocab is a set or a hash map of text to line or something. Then how do they, here, output tokens extend subtokens, cur substr. Oh, interesting. Okay. So here I see, they are not actually tokenizing the text yet. They are just splitting the big word into the 3 smaller words. I see. Okay. So that makes sense, right? This is just, they are turning a word into a chunk of subwords. Easy. Okay. Then where do they, what does the other parts of this do? Full tokenizer. Yeah, so he has vocab, inverse vocab, that makes sense. Then basic tokenizer is run, who does what? What is he outputting here? White space tokenize. Which is that the thing we were just looking at? It is. No. White space tokenize is up here. Right, this just splits the text. We already saw that. So this, again, the basic tokenizer is, again, this is not creating numbers yet, right? This is creating word pieces still. Okay. For subtoken in this thing, for token in basic tokenizer, for subtoken in word piece tokenizer, this is, again, words to words of some form. Okay, so who uses this thing? Who uses this thing? I guess maybe all of this is like before you even get into how do I say this? Before you even get into the like numbers part. Yeah, interesting. Interesting. So where do they do that conversion? That must be, it must be that once you have these tokenized pieces, then you can just look it up in the vocab, would be my guess, right? You just go by index in the vocabulary. But like, I want proof that that's the case. So how do they do that? Run. Okay, so here they have tokenization. Clean. Okay, this is all for like generating answers, which I don't really care about. I'm more curious about how they do input. You know, tokens here. Tokens. Scrolling, scrolling, scrolling. Tokens. Am I high? Tokens equals nothing here. Oh, this is still words. This is still like words here. Okay. So then when they construct this input features thing, input features has tokens as words. But then like surely that must go somewhere, you know? Run callback. Which create int feature from input IDs. Okay, so this thing already existed. How did he make input IDs, right? Input features, self input IDs is input IDs. Oh, interesting. So this was constructed before this. Input IDs would have been part of this thing, I guess. Convert tokens IDs. This is what I was looking for. This is what I was looking for, which is in tokenizer. Gotcha. Tokenizer, tokenizer, tokenizer. Convert tokens to IDs. Convert by vocab. Oh, perfect. Easy. Oh, so they just flip the I see. They just flip the array here. Okay. Wait, that's pretty straightforward, right? At least like this model's tokenization process is straightforward. But this is not necessarily what we're running, right? This is BERT. This I could write. I completely understand what I'm looking at here, right? The question becomes then, what does all of the metadata in this thing mean, right? Right? Like here they have padding rules, truncation rules. Can we just look at like, can we bypass this like hugging face tokenizer thing? Right? Like I'm using this model. Like who did this the first time? And how did they do it? You know what I mean? Because like if we can like just walk the path backwards to how they originally trained, then we don't have to worry about all of this like hugging face abstraction shit. They're like, we used this thing, so this guy came first. This is a 6-layer version of this guy. Okay, so Microsoft Mini LM. This has got to be like the same tokenization process. It has to. So original Mini LM repository, right? We would assume that all of this whole family, if they're all just like building off the existing work, their tokenizers would all be the same, right? That would be my guess. This is a sick repo, man. What a sick. Perfect. That's awesome, man. How is this useful information? Where is the code? Maybe it just doesn't exist. But like, surely if this is how they released a thing, then surely they would want to release the tokenization process. That's like an important part. Oh, Mini LM vocab nug. Okay, so here they're like just running. Interesting. Interesting, interesting, interesting. Am I high? Don't we need the, like, where is this grammar coming from? Maybe it's from, I see. I see. It's from OneDrive. I see it's from OneDrive. So this is just, yeah, I see. So we need to be, like, confident that I followed the chain correctly, but then there's some grammar defined in this guy, which is maybe where we want to start. Right? He has this guy. Oh, and beautiful. This is just, like, literally the simplest thing in the entire fucking world. Okay. Yeah, I don't see. I'm sure we're probably going to be missing something, but, like, I think that there's a lot of like layers of abstraction in this shit to just say here's a fucking list of words. It really seems that way, right? Like, am I crazy? Right? Because this, what are they doing? What do they say here? They say this is just vocab.txt file. Yeah, that's how it feels. What is he running here? Run xnli, and in this fucking file, they have the path to vocab in here, right? I think I saw that in here. Yeah, they're literally just calling, well, they have run squad. Examples. I like how their examples path doesn't have everything, but that's okay. Okay. Fuck my life. They are using some of these fancy tokenizers, huh? Oh my god, can I fucking search for text without my entire browser getting fucked? Thank you. GG's. Okay. Let's just try, right? Let's look. Okay, I'm gonna look a little closer at what this thing that we are using as our backbone says. I'm pretty sure it looks. I guess we have the vocabulary, right? And the vocabulary that we have, I think, is uncased. So I think everything's like lowercased off rip. We can double check if we look for maybe capital A to Z. There's literally no capital A to Z in the entire thing, right? So lowercase. And then we probably have to implement the word splitting thing that they were doing. There should be capital letters. I think there just aren't, though, because I think that, like, I saw something about, like, this is pre-trained from something uncased, right? So uncased you would assume just means that, like, they did lowercasing already. Because, like, I think that just reduces the amount of tokens that your thing needs to support, and because this model's tiny, right? Like, it's like 100 megabytes or something. Right, so, like, anything you can do to, like, do less is kind of nice. Okay. Yeah, I mean, I think following whatever this Bert guy was doing seems reasonable, right? The only thing I'm not entirely sure about is how they are mapping to segments, right? So how are they converting to subtokens is something that I didn't really understand yet. Is it, like, literally just, like, expensive as fuck? Right, so they have subtokens here. Cur substring. While start is less than end, start is 0, end is length characters. Oh, I see. They're literally just stepping the start string forward. Probably until they find it in the vocabulary, And then they're assuming that if they found it in the vocabulary, that this now becomes like you cut it off, right? So if you see in here, well, that doesn't make sense because this vocab has hell and hello, right? So it's not like a greedy search. If substring in self vocab, oh, they're truncating from the end. They're truncating from the end, I think. So how does start ever get bumped forwards? Start equals end. Oh, I see. Okay, I think I get it. So they're going like in some string of text. They are looking for this whole thing. This whole thing, too big, right? So they start at the end and they keep bumping this back until they find something matches, right? So if we have like hello at this point, that's like, it cuts it here. Then they search for the rest of the word prefixed with 2 pound signs. I think. And then they do the same process again. I think. Does end get reset when you do that? Yes. Yes, they do. Okay. Cool. Cool. I think I saw continuation sequence or whatever in some metadata. Yeah, I think that we don't have to worry too. I think we can like hard code a bunch of stuff, right? Because I think that we're like using the same family of vocab for everything. So I'm not like super worried about it. Okay, this is starting to make sense. It's starting to make sense. Okay, so can we make tokenizer zig? And for now, we will just do this. You know, fuck it. And what are we going to do? I guess we need to put this in our build somehow. Fuck it. Copy, paste. Tokenizer. Boom. Tokenizer. Okay. So we need to load vocab, right? That's the first piece. I guess at some point, we're kind of starting on write tokenizer. Load vocab. Path. Which means that we need some arguments. I think it's init minimal. I'm gonna say var args is init args iterate, and we say this is the process name, ignore that shit. And then the thing we do care about is this is the vocab path, which we are then putting into here, I guess. And this is our vocab, which I think this is this bidirectional right now? I think we are just doing, this is going to be like a set or a hash map, I think. Function load vocab is going to return, I guess, like a stud auto hash map, or maybe a stud auto hash map if we want to get cool with it. Hold on, we need to restart this so that the language server processes correctly. There we go. Load vocab. Can he return a stud auto, a stud util string hash map? He can. So we are going from string to unclear. Usize? Maybe? I guess we'll find out later. Yes. And this is going to be vocab path. And we're going to do like stud IO open, vocab path as F, defer F close, or I guess in our world it's stud IO close F. Beautiful. We have like a reader is stud IO reader around this guy with some reader buff. Read buff. And what are we doing? We're trying to do like split. We're trying to do R interface take delimiter exclusive. What happens if there's a new line in the vocab? Is that just marked in a funny way? Because if I just like take my new line, like, won't I just be fucking things up? You know what I mean? You know what I mean? So, how do they represent new lines in the vocab? That's my next question. It might be in one of these, like, specialized things. Might be turned into separator. Can we look at what they do in this thing if they see, like, there was, like, something about white space in here, right? They had something about... I think I saw something about white space. Is white space. We treat them as white space since they are generally considered as such if you see these things. Okay, interesting. Original tokens is white space tokenize. Okay. Runs basic white space cleaning and splitting of a piece of text. Yeah, interesting. Is white space just not included in this at all? That's kind of interesting. That's pretty interesting. Because, like, you would think that that's, like, important context in some cases. I'm surprised that that isn't a problem. And then also, like, why, if we're splitting by white space off rip, then why are they calling is white space anywhere ever? You know what I mean? You know what I mean? Because... Oh, I see. They are converting every piece of white space to a space here. Initially, it looks like. And then also doing some, like, Unicode cleanup. But I think that we maybe can get away with not doing that. Yeah, I guess because we'll know if the thing's not in the vocabulary. So I think for now we just do like something stupid. Because like what will happen if we do something invalid here is that the vocabulary just will not contain whatever chunk like string we find, and then that's fine because like that won't like run something invalid through the model. That will like fail gracefully. It seems like so. I think that's fine. Okay, cool. Okay, so it seems like we can do take delimiter exclusive, which I can't remember. Does this consume everything? Can I like run this in a loop? Returns a slice of the next bytes of buffer data from the stream until delimiter is found, advancing seek position up to but not past the limiter. I want inclusive then? Or maybe neither? Take delimiter. Returns a slice of text of the next bytes buffer to data until delimiter is found, advancing seek position past the delimiter. I think that's what I want. Return slice excludes the delimiter. End of stream is treated equivalent to a delimiter unless it would result in a length of 0 return value, in which case null is returned instead. Perfect. Perfect. That's what I want. I want take delimiter. And I'm just saying, fucking split that shit by new lines. While we can do this, while we read some shit, here is our line. And I guess we want our index here. And then we kind of say, you want to run mini LM and Zig? Yeah. Well, our like variation of mini LM. The end goal is to run this as part of our web server. You know, and so just like trying to, the plan is export trained model to Onyx. I'm okay with taking the Onyx runtime as a dependency, and then this is like, how do I prepare inputs to get them in there? Is kind of the idea. Okay. So here, I guess we have our return. Initialized with arena expansion allocator. Typical size. So I guess we kind of know. We could actually count the size of the vocab. That's a thing we could do. I think for now I'm not gonna bother. We'll just say like, you know, surely there aren't more than that many entries. You know what I mean? It's just like, fuck it, I don't care. I guess we'll fucking hard cap it. Vocab, this is like 35,000. So let's say your vocab shouldn't be more than like 64,000 times 10, or I guess like times 8, I guess, for power of 2. Like, that seems like, our vocab was, approximately 30k. Double it. 30k. 16x seems like good headroom. And then we can probably pick something where we're like, we're the smallest vocab. We'll just say this. Fuck it. That seems fine. Okay, last time we returned to Bert. Yeah. I threw in a bunch of different models. Like, I tried a bunch of different ones after training, like off stream. Constant, thank you for the prime. Okay. Create alias for token ID to use size to not mix tokens. No. You can't make me. I'll do what I want, bitch. Expansions. Stud, Alec, util, I think is where this lives. Expansion, Alec. Yeah, there we go. Cool. So for each of these things, we're saying ret. Try ret. Okay. Ret put line. And so this line needs to live for the duration of the memory's lifetime. So for the map's lifetime, right? So attaching this, I need to duplicate this string because this is a reference into the read buffer. So I need to do this. Alec U8, I guess it's dupe. Like this. Boom. And then the value is index. All right, easy. Easy peasy. So we have our vocab. I'm pretty sure that's it. I'm pretty sure that's all we have to do for this. I guess we have to return if you think about it. And then this guy's like, I need fucking arena and expansion. For now, let's just put everything on the stack. So I think that we can just kind of have like a, Alec is a stud buff allocator initialized with maybe the heap page allocator. Let's kind of allocate like, I don't know, 10 megs. Surely that's enough for us to do whatever the fuck we're doing, right? Surely. And then this is allocator, linear allocator around this thing. Boom. Easy. And then vocab path is here. And he's like, I guess we need to or else return error. Uh-oh. And then this. Okay, this does not build yet. This needs to be tried. This can fail, because allocations can fail and shit. This guy's like, yo, dog, you forgot all of the other arguments to this thing. So true. What else? This guy's like, yo, you need to try. So true. And this guy's like, you need to try. So true. Hello, LLM token. Hello. I guess SLM token with a joke that Kerniston made earlier is correct. An SLM token. Alright. So now, what are we doing? We're fucking splitting, we're iterating some input text, right? So maybe the input text is the next thing. Right? This is no vocab. And then this is no text. And I guess we are saying, so they split by white space, right? It was like, split iterator, like this is going to be, maybe we'll call it candidate iterator, right? So this is like a thing that we think might be a token, but also might not be, right? So this is going to be some sort of like split by white space on the input text, right? And then we're going to go like, while we advance this thing, while we get more token, like candidates, we are going to do like that shit they did, right? So it's like take full range of candidate, check against vocab, decrease end index by 1 until we are in the vocab, and then append, then like start sub sequence with double extension thing, and go again. Something like this. I think that this is actually a thing that exists in stud mem. Split any. I mean, we're kind of making an assumption here. This is like a bad assumption. Assuming ASCII, right? We should be a little bit more intelligent with Unicode escaping, but for now, this is going to be good enough, right? We're trying to focus more on, do we understand the whole thing than do we understand like the individual pieces, right? So like we know that UTF-8 will have a bunch more white space characters that we like also will have to deal with, or maybe we won't have to deal with, but like, this will like work assuming correct input. And I think it might be guaranteed that the Wikipedia text is within some set of reasonable constraints, right? Because it's something that has to sit inside an XML file, okay? Which kind of restricts the total amount of things that it could be by some amount, right? I don't know what. So there's like, to do like what subset of characters are valid in wiki text, right? Like there's something there, because when I pulled like the Wikipedia database the other day, it's literally like 110 gigabytes of XML, and it's like I walked that like totally fine with my XML parser, so I assume that there's some restrictions on there. You know what I mean? Okay, so we have some candidate. While I think we want candidate in here, so we can say candidate is candidate in, because we're gonna like be updating this thing, right? While candidate len is greater than 0, we're going to be doing something. And I think, yeah, that seems reasonable. I think we're keeping an end index here as well. Right? Something like this. Something like this. And so we are saying, like, does vocab get candidate, or else end minus equals 1 and continue. We need to check. I guess this is from 0 to end. Here is the trick. This is the token. So we append this somewhere. Maybe we'll just do this for now. Just write it and figure out what we want to do with it later. Okay. Then, so if we find it, it's like candidate is equal to candidate from end onwards, I guess, right? Okay. But we need to tack on the double what do you call it? The 2 hashes. So if we want that as like a contiguous chunk of memory, which is a little annoying. So maybe we will just make like a candidate buff here instead. Right, so we'll copy this thing into this thing, which is like a little bit annoying. Where we say stud format buff print into the candidate buffer of this followed by the rest of the string, which is candidate from end onwards. Oh, perfect. Wait, that's easy. And I think, like, memory-wise, this is fine, I think. Yeah, this buffer outlives this loop, which is where we might be referencing this thing. I think we're fine, yeah. Perfect. Okay. Cool. Okay, we have to put unc in there somehow. maybe we actually are just printing the maybe we're printing the string here instead. I think that makes more sense for now. Right? Maybe we will put a map here into the token ID as well. That seems fine to me. Cool. Easy peasy. And then now what? End is this. This is like this. I guess we say like if end is equal to candidate len, we need to do something, we need to break, right? Break out of this loop. And somewhere we need to decide that we did not find it, right? So maybe this is I think you can say here like success is false. Maybe here we say success is true. And then if we make it through this whole thing, then we didn't find anything. So if we didn't succeed, we say unk, which is, I think, in the vocab as unk. Like this, unk, or else return error, no, no unk. Okay, and then we can just right here put unk to unk. Right, that seems like something. And then we go to the next candidate. All right, cool. How does this work? Vocab. So our vocab was this from this guy from here, and then our text is hello world. All right. I guess we are forgetting, we forgot that we have to put the initial thing, right? So we need to start with this like start of string, start of stream, I guess. So I guess maybe what we do for now is I don't know. What was the example that they were giving here, by the way, for their tokenization test? I want to like recreate. You know what I mean? What was their example? Unaffable. Unaffable. Okay, that's a bad sign. We're like infinite looping. Why are we infinite looping? What the fuck? Hello? Like, what the fuck is happening? That is spamming. And then presumably we are in here, right? Oh. End has to come up here. End is one level too high up? No. Oh. Yeah, he does have to come up here. And then we have to set end to, like, when we update this thing, we set end to the new candidate line here. Not bad. Not bad. Unaffable. Unaffable. That's a crazy way to split that. Is that correct? Yeah, it feels like we're off by one, right? Unless our vocab's different. So we got 14477. Can we look at that? It is Anna. And then with the other thing is fa. Yeah, I mean, maybe that is just correct. Maybe that's correct. All right. Fuck it. Okay. So what is like a good way to test this? The dream is that we are like 100% confident that we've generated the same thing. So like what we could do is we could rip the existing tokenizer in Python over all streams of over everything in like the training set and check that the tokenized output is exactly the same. We're also missing a piece, by the way. There were two outputs of the tokenizer, right? There was like in inference, there was input IDs and attention mask. What the fuck is that? What the fuck is this? I don't even know what that means. Like like what is this concept? Attention masking. Oh, is this literally just like you apply the mask to the input? Yeah, if you're like, hey, I want to make sure you fucking ignore these. Is he literally just like multiplying them together? Scores is scores masked fill with negative. Yeah, he's literally just zeroing out things in the mask. Which is like, maybe your tokenizer has rules for tokens that you wanted to ignore, but were in the vocabulary. I don't know why the fuck you would ever do that. I guess maybe you want to mask out unknowns, right? Like there might be anything that is unk. Maybe you want to make sure that the scores for those things are negative infinity so that attention doesn't look at them. Maybe. Okay. Yeah, what the fuck? What does that JSON blob we were looking at say anything that like gives us clues? Right? So we have this guy. We have like tokenizer.json and tokenizer config. Let's start here. Mask. I guess he has the word mask in there. Mask. He yeah, nothing too like super duper interesting there. What about in config JSON? He has a mask token. Okay. Interesting. So presumably the mask token results in things being masked in the output of the tokenizer, right? But like, where does this mask token come from, right? Because like, we're never going to insert this, right? Like, we're going to insert unknown token. We would maybe insert separated tokens, like at the end of stream. Like, we would insert the start of streams token. But like, where does this mask thing ever come from? That's confusing. Maybe it's time to look at the tokenizer source code from Hugging Face, because I'm quite confused about that, like as a concept. You know what I mean? Mask. Is this a thing that exists in here? Yeah. Okay. So this guy does like output attention mask in here, right? Okay. So what is this thing doing? Pair. Merge with. Okay, that's not very helpful. Attention. Can we like look for like attention mask? What is it in this language? Push? If it's a vector? This is literally the only place. So here they are saying they put a 1 anytime there's a token. Of course. Of course. What else would it fucking be? I suspect that what's happening is like, I think that for training these neural networks, they zero out some sections, right? I think like the training of this is like hi, my name is Mick, right? And then I think to train, like, get like embeddings for these guys, they just kind of like delete the word name and they say like, could you fucking figure out what that is? Right? And so I assume that's what's happening is they are like tokenizing the text, then saying, hey, during training, zero, like, we zero this out with the attention mask, but the token's still there, and then your like loss at the end would be like, did it predict the right token for name at the end, right? So you'll have like, you know, name token plus 0 for mask, and then later you just say does name token equal name token at the end. So presumably, like, we just rip ones for the attention mask no matter what. That would be my guess. We could. How can we prove this? Or at least like semi-prove it. We can run the Python tokenizer over some text and just assert that no matter what, it's always ones. I think that that's the play, right? We just assert that it's full of ones. So that'll be in our repo. We're not in our repo right now. Fucking dumb fuck. Can we look for like train is where I would like to put an assertion for this thing, right? I would just like to say like in here. Well, we have tokenized tests. Let's do this. Print ink attention. What was it? Attention mask? Was that what it was called? I can't remember. We'll find out. He's working hard. Yeah, okay, so it is all ones, and then we want to put an assertion here that's like ink attention mask. What's like the easiest way to do this? Sum, and then equals attention mask shape. I think that this is probably the way. Is there an easier way? I don't think so. That seems like pretty clean. He doesn't like this. Why? That is assertion failure. God damn it. Print these two things, how about? Because I'm too fucking stupid. Let's see. Oh, it's double nested. It's double nested. I guess we can do like for each element of shape, you can do like, I guess you go from shape 1 onwards. How the fuck do you do this in this language? Like this? For val in this, like total len times equals val, and then you have val is equal to shape 0. And then I think that kind of gives, like, if this thing happens to spit out something else, this will still be correct. So this should be like expected attention mask sum, we'll say. There we go. Expected attention mask sum. I think this makes sense. I think. Did I fucking spell it wrong? I did. Expected. There we go. Rip it, baby. Okay, cool. 7 and 7. Cool. So now we should be able to like assert that this is correct. Cool. And then I think we just try to rip this over like as much text as fucking possible, right? So I think we just go like we at least have our pre-processed samples in here. So I think if we just run it all over everything there, then we're like in pretty good shape, at least to be fairly confident in our guess. I mean, fairly confident is low confidence in our world, but like, you know, high enough confidence that we won't think about it again. You know what I fucking mean? You know what I mean? So import from pathlib, import path. Then we go path, what is it? It's inputs, preprocessed, iter for p in this. Let's do a little with open, p as f read into content. Then we can do a little bit of enc content like this. There is some, interesting things in here, by the way. But that's okay. This is tokenizer, sorry. Enc equals, and then we say assert this, please. And let's just assert false here just to make sure that we are getting into this part of the code, right? I want to make sure that this is behaving the way I expect, so we should crash. Well, instead he's saying that's not fucking defined. It's like, yeah, we're fucking idiots. This all has to come up here. Okay, run that again, double check. Boom, assert false goes away, delete this, and it should just rip through everything, and it should just work. Boom, right? Okay, so that's a fairly good sign, right? I think that like the hypothesis for why this thing even exists is reasonable, right? And I think that we have like some level of confidence that is correct, right? So I think that means the only thing we have to do here is like double check that our tokenized text is the same. So maybe what we do is here we like take everything in the preprocessed text segment, and then put next to it a just space separated list of numbers. Yeah. So can we just do like major tokenize, or maybe we'll just call it .tokenize or something. So for p in path, if p suffix is equal to tokenized, continue, right? So that, and then we can write to that thing. We can say with open, I think it's like stir p plus .tokenized in write mode as f. You need to do some sort of like intelligent printing here, right? How the fuck do you do like print formatted text? I guess with an f string, right? In this language. So you just would go like just number for ID in enc input IDs. Why is this blue? Why is that blue? That's concerning. That's nothing else is blue. What the fuck? That's fine. We'll figure it out. And then, is that really it? Right, that seems kind of right. Maybe, ID is a, maybe reserved word. Tok. Okay, so now in this thing, we should see the fuck. Right, fucking PyTorch. To list, I think is the way, right? What language you use at work? Oh, it's an easy fix. Easy answer. I just don't have a job. Perfect. This is not what it should look like, by the way. Why is it outputting the brackets? What the? Am I fucking high out of my fucking mind? For this and this, print, talk? Like, what are we fucking doing? I guess. Like, what the fuck are we doing here? Oh, it's double nested. It's double nested. Right, because it's giving us a batch. So we want to make sure that like this. We want to say assert that this shape 0 is equal to 1, and then we will just put a 0 here. And then that should make more sense. There we go. Perfect. And then we put this in here with the space, with the trailing space. Fuck my life. This should be 0 here. Okay, and then inputs, preprocessed, tokenized. That looks like a fucking space delimited set of numbers, baby. And so now what we can do in our tokenizer Zig implementation is just make sure that we get the same fucking answer. Right? So we go, now we are trying to iterate a directory. So this is, I guess we have our like, our processed dir is we're no longer getting text. We are now getting input dir. And we are saying, we have some dir iterator, which is looking at, I guess we have, this is the input path, we should call this. Input dir path. And then we have const dir is an open of input dir path, with is flagged as a directory so that we get our iterator stuff. And we are in read mode, so we don't have to set permissions. We can be good citizens even though we're in main, and close this thing. And we're saying var dir iter, I think we have something for this, is directory iterator initialized with this dir and dir iter buff. I think this is where the kernel stores like file names and stuff. Dir iter buff. Let's give it 4K. Everything's 4K. We always give everything 4K. It's a number we like. We like that number. And then we say, while this thing next, we get some entry. And I guess we are doing the same check for, we are skipping anything that ends in .tokenize. So if stud mem equal entry name, I guess ends with .tokenized, we say fuck you. Otherwise, we load the file. So I guess we say content file is going to be a open at of the directory that we are iterating with the entry name of this thing, right? Yep, flags are default because we're just doing a read only, and permission 0, easy peasy. Okay. And then we have the what is the other thing that we're looking at? It's the like expected tokens file. And here we need like expected tokens path is going to be some sort of maybe like buff print null terminated of expected tokens path buff with the entry name followed by tokenized. Easy. Easy. So the expected file is stud io open at dir expected tokens path. Also read only. Okay. And then I guess we need expected tokens path buff. We should just use allocators. It's when you write Python and then flip right back to Zig, you go like, man, managing memory is a pain in the ass, right? But if we were just willing to allocate here, then like we don't have to do this, which makes our lives like a little bit nicer. Expected tokens file. Get the fuck out of here, bitch. Okay. So we want like our tokens. Tokenized is going to be tokenize content file with the vocab, I guess, right? Like something like this, which means that like everything that was down here, I guess, goes into a function. Pub function tokenize. And this guy's going to return, I guess, a list of usize. Just format AlecPrint into global arena. He's a genius. He's a genius. And what do you say we were taking here? The vocab as vocab. Can we just fucking, you know, give a little name for this guy so I don't have to type him over and over again? Okay, my vocab is a vocab. Easy. And then what was the other thing? What was the other thing we were fucking passing? Oh, the file. I guess this should be like a reader, right? This should be, if we want like a semi-sane API, this should be a stood IO reader. And I guess we need an allocator for the output. Right, easy peasy. Yeah, I mean, I guess getting him as a buffer is fine as well. Let's do that. I'd rather not think about streaming data. It's just easier not to. Okay. Okay, so we're gonna have our return is a stood array list of usize, who is initially empty. We are gonna return that thing at the end. And then what? I guess we are going to append to that thing every time we would have printed before. Right here and here. No. Yes. Okay. Sure. And then of course this will be broken, but that's okay. We'll fix the problems as they come. So we have tokenize, who needs a scratch allocator, which by the way, if we're doing that, we might as well do AlecPrint here with scratch allocator. Isn't that nicer? And then, oopsies, do we have our scratch? Scratch is the backside of our big buffer. And then here we just say like checkpoint is scratch checkpoint. Yeah. Why does he, what's the fuck is going on? Oh, backlinear. And then defer scratch restore checkpoint. Easy. Then we can just use that everywhere in here without thinking. No thinking aloud. Have we not loaded our vocab yet? We have not. So the vocab gets loaded here. Token sized, tokenized, and then I guess we're going like 4. I guess we're trying to like expected is like parse expected of expected tokens file, I guess. This is like content, like content is supposed to be this. So we need to do a little how do you do this quickly? You do like a reader of content file. Stud IO reader of content file. I think unbuffered, and then we can just do like R interface alloc remaining. Like this. I think this is how you do this. Yeah, I think it's like this. Uh-huh. Easy. And then for the expected tokens, I think that's fine. We give them this. Is there anything else you need for this thing? You need the allocator as well, probably, right? And then you're going like you're like grouping, I guess you're just like asserting that tokenized len is equal to expected len, right? And then you will want to like loop those things together. I guess we should fail in this case, right? Let's say if this is not true, return an error. No. Right? Just no. Perfect. And then for tokenized expected AB, right? If A is not equal to B, return no. No. And then this all has to go to function now, right? So all of this is going to go inside like check expected probably, right? Because we could go like check expected, tokenized expected, catch E, and then if that is the case, we can just print the two things, right? We can say and then we can just print the two things. Tokenized expected. And then maybe we should also put the name of what failed, so we can take a little closer look if we need. That seems okay, right? And then this just goes in check expected. Right, like this. Boom. Boom, boom, boom. Okay, so now we just need parse expected. Which is taking, what, a file? And an allocator? Yeah. So I guess it's like a ret is a std array list of indexes. We return that thing later, and then we say while true, or I guess we have like some reader. Var r is an reader. I think we actually want a buff here. Buffer reading is kind of hype. We say take delimiter of space. While this, we say ret append a parse of this thing into a usize. We're taking text and base 10 with allocator. All right. I think that's it. Then all of this is just dead, I think. Like we copy pasted that somewhere. Maybe we bail out on first error. Seems fine to me. Like that's easier for now. And then he wants the path now, which is inputs. Hello? Oh, it's not in dot slash. So we're not in Zig. There we go. Inputs preprocessed. I think that's it. He's mad because expected I32 and dir iter. Excuse me, I unitary type try, you idiot. Thank you. Here he's like, yo, dog. Oh, hold on. Hold. I'm not in the right directory for this to like work correctly. Okay, now he's like, yo, dog, that needs to be aligned by 8. All right, if you say so. This thing probably needs to be tried. This thing's like, yo, dog, this is a slice. So true. This guy is like, you need to be in the alternator, you idiot. Is there no like alloc print sentinel? I see. And then he wants the Z here. Here he's like, yo, dog, you need an allocator. So true. Scratch allocator. Easy. This is like, yo, you didn't write try. True. True dat. This thing you didn't write try. True dat. This thing you need to return a list of U sizes, not U8s. True. This thing you write try. Make please. Thank you. Zig build. Tokenizer. That looks good. Read failed. Is dir. Am I fucking stupid? This is on 112. fuck? Opening this. Opening dot. Oh, right. I forgot. Of course. Why would my directory iterator fucking ignore? Why would it ignore dot and dot dot? Why would it? Of course it doesn't. Of fucking course it doesn't. N minus equals 1 at 44. If n equals 0, break. Surely, right? Okay. Memcopy arguments alias. Oh, that's interesting. What the fuck? Why is that happening? Oh, because the candidate is already in the candidate buffer. That's a good point. Wow, good job. Good catch. Huh. So what do? We can do a mem move instead. Or we could like double buffer. Or we could alloc. Yeah, that's annoying. I think what we do here's the play. You do candidate buff. You just always have this to have the double thing pound at the beginning. And then you say candidate buff from 2 onwards is like a mem move, which allows you to copy over. But we are trying to scope this thing, so this is candidate len plus 2. Perfect. And then we just say candidate here. And then that will work, I think. Instead of this buff print. I think. Oh, fucking no. Oh, fucking no. Out of memory. Oh, I guess we also have to say candidate here is equal to candidate buff to candidate len plus 2 for this to work. It's like something like this. But then somebody else is out of memory. Maybe reasonably, maybe not. That's not good. That's not good. Why is he freaking out? You draw a wrapper so that your error messages are like, yo dog, this fucking sucks. True. Have I done this wrong? Function copies bytes from one region memory into another, but unlike memcopy, they may overlap. Dest is the thing, and there's a mutable slice, a mutable pointer to an array, or mutable item pointer, source must be a slice. That seems right to me. Then why are we infinite looping? Nowhere should we be infinite looping. I guess maybe in like some of the new code we wrote? Right, like whatever we're doing is stupid. So let's, I guess, just start putting some fucking logs. Stood debug print. Tokenizing. And then this is expected. And this is, I guess we can also say, tokenizing done. Like, are we stupid? Yeah, okay. So he is just getting stuck in here. Why? Candidate. We're doing something stupid? Candidate equals. He's just looping in here forever, I guess. Oh, because here, the candidate length here is always going to be at least 2. That's funny. If, I see. Yeah, we fucked up here, right? Because we were supposed to be looking at candidate from end onwards, I think, down here. We must have lost that by mistake. Because here we're just copying the whole thing again. Yeah. So this should be like end dot dot, but then also we should be like new segment is this, and then if new segment len is equal to 0, we break. And then this is now while true. This is never limited, actually. I guess that's still useful. And then he does this. I think that makes sense. Okay. Destination arguments have unequal lengths. Yeah, true. Why is he looping forever still? Oh, new segment should be here. And then this should be new segment len plus 2. Does that make everything work? Candidate is equal to new yep. New segment len here. End is candidate. I think that all makes sense. Perfect. Perfect. That's looking a little bit better. We are ooming though, out of memory. That's interesting. In tokenize. Why? Maybe, like, that's surprising to me. This is in... Are we forgetting to reset our allocator somewhere? Or is it literally just taking up so much fucking RAM? Appending this. Like, we're not, like, spam appending the same thing forever, right? In, like, an infinite loop. I mean, that's not looking promising. That's not looking promising. Right? That would do it. Yeah, there's something wrong happening here. We've done something wrong. I can't see it yet. Side note? Yeah, I'm lost on something. I don't know what yet, but I am a little confused. Candidate len, while candidate len is greater than 0, we get this thing. Can we just print here? Like, what the fuck are we doing? What the fuck are we doing? That we're doing something dumb, let me tell you. Let me tell you. So we gotta be getting here, right? We gotta be getting here. Shockingly, not every time. But when we do get there... When we do get there... We're not getting to the, like, candidate ever, right? Yeah, we're... New segment is our candidate from the end position onwards. Am I fucking crazy? New segment. So he's saying, like, hey, your new segment is golden onwards. Because I found the double... he's like, I found in the token list an a double hash. And then we are then appending your thing to, yeah, okay. We have to check if the thing that it found is double hash, then we need to like break the fuck out of this, right? If yeah. Yeah. It's like if end equals 2 and token and yeah, if we are at this and candidate 0 to 2 is equal to this, that's a problem. That makes sense. We're really never hitting that? How? Hello? Why the fuck not? Hello? What am I missing? What am I missing? The fuck? What the fuck? Am I fucking losing my mind? Cause here, high end new segment, like what? Oh, okay. So he's consuming the triple hash, then being like, okay, now this is double hash golden. Then surely double hash golden is never found, and maybe that's somehow getting us into this triple hash state? Oh, yeah. I think I'm seeing it. So he's going from like... Oh, that's funny. Yeah, so he's like, hashtag, that's a nice token, right? And then he's like, oh, yeah. So he's like, yeah, that's a fucking token. But then I've got this like remaining like hashtag golden at the end. And he's like, okay, so I've got hashtag golden. So I will prefix hashtag golden with 2 hashes. And then I will find the first hash. Or then I'll find that the triple hash is valid. That's so funny. That's so funny. So we have to like somehow ban the idea that like double hash is not okay, or we have to like mark the separator like in a way that's not just text inline. That's so funny. I think we just say like min end here. I think that's the play. So like on your initial input, your minimum end is 0. But here it's like if end is less than equals min end instead of 0, we're like, no, get the fuck out of here. You know what I mean? Then when we reset and add in that thing, we set min end to 2. Beautiful. Okay, now that's working better. We're probably getting UNC tokens now. Because I think that did we not lowercase this thing? Right, we're supposed to be lowercasing our inputs. Which I think we're not doing. By the way. We're gonna assume this again. Why not write a test? I mean, this is essentially a test. We're like running, we are running a program that is validating that the inputs and the outputs are the same. I don't know how much more of a test you could want, other than you just want like the word test in there. But like, I mean, that is exactly what this is saying, right? He's like, yo, dog, those aren't the same. Which I think is reasonable. So we are like clearly forgetting the start token 101. So we should have a CLS like this. No CLS, and then we also need SEP. So at the beginning of this whole thing, we're supposed to drop a CLS in there. And at the very end, we're supposed to drop a SEP. Cool. Or else wrong. I mean, it's not wrong in a way that matters, but you're right. And then this guy, can we like lower into the candidate buff maybe? Sorry, I'm thinking. Yeah, I think that we can reuse this candidate buff in yet another way. I think. We're getting a little too clever for our own good here, but also like fuck you, you can't stop me. You know what I mean? So this is the candidate in, this is candidate. Now candidate is always in this buff. I guess we can kind of do 2 onwards here, and then everything just kind of works. That's kind of funny. Yeah, that's funny. I think everything works if we do that. Okay. So now, what is wrong here? We need to like format this a little bit nicer, right? So that we can like see it. So on, can we just hit a couple new lines? That is still not nice enough, but I mean, we'll live. Here is the first thing that's wrong, right? So we go, sorry, here. It's right here. We get 1011 here instead of 29624. So we need to look at what those two things are in the vocabulary, I guess. Which were 1011, but off by 1. So we've got like a dash or something in there, and they got 29624. Okay, I see. They had separator followed by a dash, and we just had dash. Which is kind of interesting. That's interesting. What is our candidates here? Maybe we're fucking up the insertion of the double thing, but I don't think we should be. Let's just go back to logging only candidates, I think. So this is, yeah, it's fine. Okay, so we're looking towards the beginning of this entire shebang. Candidate, Spider-Man. Then we immediately go to sep dash, which then turns into, oh wait, that seems right. Right, so we have like extension token dash, extension token man. Wait, that seems fine. But we are not we are consuming the dash instead. Are we fucking this up? Can we print here? Go back to printing like found this, which maps to this number, right? Like what the fuck is going on here? So this is candidate from 0 to end with the number. Token. I keep hearing rumors that we're gonna drop tokens and switch to byte streams. Everyone keeps shipping tokens. That would be cool. That would be cool. Oh! I'm backwards. 29624 was me. So they consider the dash a new word. Oh, Lord. Oh, fuck me. So our white space split has to get like insane, no? Oh, that's fucked. Because the dash is like a separator and a token, where like our white space split was not. You know what I mean? So we need to write like a more advanced like candidate splitter. Okay, and then is that like defined in the grammar that we saw anywhere? Because like that's like very just kind of like surprising behavior. Both are valid. No. No, because we're kind of saying these are one word, and it's saying like the model is expecting those to be different words. Okay. Are they using built on in is whitespace? Yeah, I'd probably not. Probably not. So like, how do you even? Oh, you know what? We saw in that Bert guy thing, we saw him doing like a pre-pass on the white space shit. You know what I mean? Like we did see some sort of weird pre-pass that we just kind of ignored, but maybe that's important. Right? He called clean text. And do you think clean text is doing things like converting dashes into space surrounded dashes? Yeah. Splits punctuation on a piece of text, right? So if he sees punctuation and it's one of these, then he's like inserting a space around them or something. Yeah. Okay. So we just need this. But it doesn't include dash in the comment? I don't see that anywhere. I'm pretty sure dash is going to be in here, right? If we just like do man ASCII and we look for what's the value of dash, I can't tell if that's an underscore or a dash. Do you guys think that's a dash or underscore? That's surely a dash. So 2D, or in decimal, sorry, I guess, that's 45. 45 is in this range, right? So they are counting it. They are counting it. Okay. Okay, so what are we doing here? We're trying to make like a candidate iter, right? And it's like, I guess this is just gonna be more advanced, right? We're gonna have like a next function who is looking at some buffer, probably, right? And he's at some position, right? And he's gonna return some buffer, probably. And it's gonna be like, we're gonna keep walking forwards while true, self-index plus equals 1. We are probably looking at buff at self-index. And we are probably switching on this thing, right? And it's like, maybe it's if. So it's like, stood ASCII is white space. C, we do buff, we return ret is 0 to index, or yeah, I think. We then probably say self buff is equal to we consume the space, but we don't know that that's valid necessarily, which is kind of funny. So like what we want to do is we want to say self buff is self index plus 1 onwards, right? To say like start from there, but there's a chance that that's not valid. So I think that we want to say like maybe we just put a little helper in here that's like consume. Yeah, and that's going to be like a number of characters, I think. And then he's going to be like self, I think he resets index here no matter what. And he sets the buff, I assume he needs self here, huh? To like if cars, maybe we call this amount, I think it's about name. If amount is greater than self buff len minus greater than or equal to, I think, then self buff becomes an empty string. Otherwise, we can move the buffer to amount onwards. Easy. And then now we can do like say here self consume index len plus 1, right? Because like we're consuming when it's white space, we want to discard the white space, and then we can do this in a defer, which lets us just return here. Okay, that's kind of functional. Else if, and then we say like is punctuation, which we copy from that other guy. And here we do not consume the value itself, right? So we allow that to be part of it. Now, the problem here is in this scenario, like we need to handle this differently if we are at index 0 or if we're not, right? So if index is 0, we want to consume 1 and return this. Otherwise, we consume up until the punctuation. So here we will say we are the punctuation, export as single car, and then here it's like consume up until the punctuation, leaving it behind for next iter. And then here is return up to white space, but consume white space for later. And then here we also probably have to we have to be careful here because we need to continuously consume white space if there's more than one piece of it. You know what I mean? Like if the length of this is 0, then like maybe we shouldn't return, but maybe that will be naturally caught later, right? So maybe that's fine. That's probably fine. I think it's probably fine. Okay. So now we just need like is punctuation, where we just copy paste what they wrote over here. We'll call it CP because they called it CP. This is like this. This is like this. And then we just don't do this. We'll put a little fix me Unicode LOL, and we should probably put that up here as well. Okay, but hopefully now we can use our little candidate iterator instead of whatever the fuck we were doing. So there's somewhere we're like splitting on white space, and we should just not be doing that anymore. Here we go. Candidate iter. buff is input text. Index is 0. Okay. We are in trouble at 12. He's like, yo, dog. So, I guess it's like, while self index is less self buff len. If we get to the end of this thing, then we must have to return if, I guess it's like, if buff len is 0, we return null. Otherwise, we are on the last guy. So it's like consume index return self buff. I think that makes sense. Okay, we actually make it to the end, so that's promising. And it does look like we have done a little bit better. Maybe. Well, here we've got a 100 in an unexpected position, right? So here we are matching 1027, 1027, 6804, 6804, 1011, 1011. So we did fix the like dash problem, but we now have a new problem where we are inserting a 100 for no fucking reason. So what is 100? Found this. That 100 is never even logged, which means it's like taking some other path. Is 100 unc? Is it like if the length is 0, we're not doing something correctly? I'm just gonna throw this in here just in case. And that does make things a little better. So we are probably doing like a 0 length somewhere in here. I can always count on you. You're the best pre-recorded live streamer in the world, hands down. I think no. No. Okay. Where are we fucking up now? This is all looking correct to me. Is it the end? By here, we're definitely shifted, right? Because we're like off by some here. Where does the beginning of line start to look wrong? Here. So 1997, we're off by some here. 2415 lines up. Diffing by eyeball. Is this a good use of my time? Here. It's 30051 instead of 1516 is where this starts to fall over. So what we got here, 3051, which is, oh, I mean, this is just a bug, right? Don't tell me that they're using a Unicode dash in here. Don't tell me that this isn't the fucking dash, dude. Don't do it to me. Don't do it to me, please. Don't do it to me. Fuck! Ah, we need proper Unicode support! Fuck! Alright. Yeah, what can you fucking say? You need Unicode. I don't want to deal with that right now, though. I hoped we could get away with it. Stood Unicode? Yeah, I mean, it exists, right? Like, what do they have? Stood Unicode Zig. Like, where are we looking? In here, 016, standard library. Unicode. We have, like, UTF-8 decode, which gives me a code point. And then, presumably, like, we need to start, like, inspecting the code points in some way, right? So like, is there a rule for like what was their rule in their thing that they were using? They had like Unicode data category. Fuck my life. Is Unicode punctuation? Is that just like a fucking like like, how do I check if Unicode code point is punctuation? It must be like some range, right? It must be. Fuck my life. Oh, this is okay. I'm gonna think about this because there's like more to this problem, right? This is like a little concerning because we are taking like unfiltered text from the internet and we are like feeding it directly into this thing, right? Which means that like now, like I just didn't consider this part. So it's every single way that every single Unicode character is handled has to be handled in like an identical way. You know what I mean? And so like maybe the trick that we can do is we can just dodge this problem altogether if we just strip any Unicode characters out of the training. Like that honestly might be easier and for our purposes would be fine. Right? Like any non-ASCII characters, like for our purposes, we're like just opening a Wikipedia page and we're literally just trying to correlate like the letters DVD or Netflix with like a date. And the dates surely are ASCII numbers, and surely all of the like relevant text is ASCII as well. So I think that there's like a good chance that we can just dodge this problem entirely if we just, as part of the pre-processing step, strip all Unicode. And I think that what that means is that I want to double check that if I train a model doing that it still gets good answers. Right? So I think what I'm going to do is assume for now that what we've done is correct, which is like a bad assumption, right? But like assume for now, and then I'm going to go and off stream. Well, just like as part, like a part of the pre-processing step, just strip any characters that aren't Unicode and then retrain, which is going to take like hours, right? Because generating the labels for training takes hours because like every single potential date in the text gets passed through an LLM, which is slow. But like, by the way, I managed to make it go a lot faster than it was the other day on stream by like picking a non-thinking model that was like relatively small and then being a little bit more aggressive on pre-processing. So I like look for if there's a year or a month in the text, and I only feed stuff to the LM if those two things are true. One of those two things are true, which sped it up a lot. But yeah, I think I'm going to reprocess no Unicode. Yeah, strip all Unicode or strip all non-ASCII, and then that just makes the problem way easier. Yeah, cool. This was informative. I mean, the core of what is happening in this tokenizer is actually like not that complicated. There's also something funny there where you could actually probably get a way fucking smaller model if you just stripped all Unicode, right? Because there's probably a bunch of information in the model that is related to like the idea that like a dash, like that the Unicode dash here is like the same thing to a human eye as this dash, right? Like there's probably a bunch of information in there like that. And so it's kind of funny that we could like heavily limit the token space by doing what I'm saying. So you could get away with a smaller model. Anyways, we'll see. What if you have a date field that has a dash in the Unicode? I think the chances of Wikipedia text having date date in the wiki text that looks like 2026 05 03 or something like that, like this should never show up on Wikipedia. And the reason for that is because in the US, this like in the US and Canada, two countries that are right next to each other, the month and like this is like completely ambiguous, right? Because I think in one they do like, oh, here we'll see, Canada date format. Like we flip the year, the months and days relative to the US, right? So on Wikipedia, just on an English site, you can't have that because you don't know which one's which. right? So date notation in Canada uses year, month, day. Date notation in the US, they use year, month, day. Oh, it is consistent. But here they use day, month, year. And I know that I'm pretty sure I've seen that in some places it's reversed. Oh, maybe in Canada we took what the US does, but the UK does it the other way. Okay, maybe. Only the slash version changes, I think. I see. I'm sorry. What a dumb, stupid fucking thought of mine. I should have known that the dashes are always the same, but the slashes are different. Of fucking course. Why would it, why not? Why the fuck not? Okay, well, I was going to say the chances of these numbers showing up this way is extremely slim because, like, you don't want to add that confusion. But I guess with dashes, maybe it won't. But I think that I am willing for now to lose any dates that have date notation as number with non-ASCII dashes. You know what? I'm willing to just not parse that correctly. I'll fucking say it. I'm willing. It doesn't, that's a crazy thing for me to have to worry about. All right. Yeah. So I think, okay, next steps. Strip non-ASCII characters. Retrain, see what happens. That is the plan for off stream today. So, cool. I think that, it's a success of some form, right? We definitely have something that resembles the correct thing for some amount of text, right? We're missing a couple things, but like the idea of like it's just a fucking list of words, I think that's holding. And we're just kind of fucking up the processing in the middle because of Unicode, but I think we're good. So we'll call it there. Thanks for watching. YouTube, peace. Twitch, let's find someone to raid.